Hello calculus students and general seekers of truth. Welcome to the video lesson on integration by parts. And we have a goal here that is to evaluate the antiderivative of the natural log function and some other integrals too. The focus is really the other integrals, but we'll start with the natural log as a good way to illustrate the concept. So what I've written down here is the product rule for differentiation. F times g, the derivative of that, is equal to the derivative of f times g plus f times the derivative of g. So naturally, if we take the integral of both sides with respect to dx, on the left side we simply get f of x times g of x. And on the right side, well, we can actually separate those two integrals into the antiderivative of f prime g dx plus the antiderivative of f g prime dx. Okay. And if I want to go a step further, I can just rearrange and I get f times g minus this integral right here, the integral of f prime g dx is equal to the integral of f g prime dx. Okay. And you can see here all we've really done is started with the product rule, went backwards and took the antiderivative and sort of apply some algebraic properties and just push things around, and we get to this result. And this is, I guess, somewhat of a theorem, but we really just proved it, and this is called integration by parts. Okay? In other words, if we have to integrate something, we look at the problem and we split it into two functions. One of it we call f, and the other of it we call g prime, and then we apply this rule. And so let's see how this works in this particular problem, where we want to find the antiderivative of the natural log function. And what we're going to do is try to split this into f and g prime, f into f and g prime. And here, well, there's really not two different functions, so we can use one as our other function. Okay? And what these problems come down to is what your decision is regarding f and regarding g prime. Okay? And if you notice here, in order to evaluate this integral, we're going to have to take the antiderivative of g, and we're going to have to take the derivative of f. So whichever you pick to be g prime should be very easy to antiderive or to integrate. And whatever you pick to be f should be simpler, should get simpler as you take the derivative. So in this case, we're going to say that 1 is equal to g prime, and natural log of x is going to equal f. Okay? So this is effectively the antiderivative of f times g prime dx, and I'm omitting the variable just to avoid some clutter there. Right, so that's this part right here. So now we can apply the rule. It's f times g minus the antiderivative of f prime g dx. Okay. Well, so we have the antiderivative of the natural log is equal to, now f we've chosen to be the natural log, times g, well, g prime is 1, so g is the antiderivative of 1, which is x, minus the integral of f prime. F is the natural log function, so f prime is 1 over x, and g again is the antiderivative of g prime, which is x dx. Okay. So then this is equal to x natural log x minus, and this integral here is the integral of 1 because you have x over x. So that's just going to be x, and plus a constant. So there we have it. The antiderivative of the natural log function is x times the natural log minus x plus c. So there, it's our first example of applying integration by parts. I'll end this video here, and we'll look at a few other examples.